My name's Gary Osman and I'm with SOPREMA. This is going to be a presentation really dealing with window detail, looking at the different conditions you want to take a look at and consider as we take a look at what kind of membrane am I going to try to apply to seal up the windows. So having said that, I'd like you to, there we go. This is my friend Eddie No Money. Eddie No Money is a builder developer. He's building lots of commercial buildings, but unfortunately my friend Eddie Money has no money because of high energy costs. Never mind the hydro story. This is about heating and cooling the building over time. And what he's also seeing, he's under a deluge of constant repairs. Water seems to be getting in, trickling, always costing him money. We call this acute air leakage syndrome. It's a common phenomenon with a lot of buildings, and this presentation is about how the heck are we going to stop it. The real question becomes, that's a formatting issue, not my spelling. How does this happen? Look around you. This entire venue is about air barrier technology. We all know the issues that if air can pass through the wall, it's going to create some type of problem one way or the other. So we clearly know that we have to make critical connections to wall, wall to roof, and wall to foundation. But the new frontier is really taking a look at those other critical penetrations as opposed to connections, dealing with wall openings, door openings, and different types of penetrations of the exterior facade, be it mechanical, be it electrical. The issue, or the reason why this becomes such a critical realm of construction at this point in time, because for the most part, your air barrier contractor is going to be looking after all this. But once we get into these types of details, it's a whole new set of trades coming on. And it's helping and working with these people to understand the consequences and the conflicts of not doing this correctly. So this is really where I'm going to be focusing a lot of this conversation on. You need to be aware there's new standards in the building code. Everybody get to read a building code these days? Somebody put their hands up. It's more than good practice now. We've been pushing and preaching this sort of terminology and technology for a long time as a good idea, and we have to do it. But it's more than good practice. It's in the building code. You'll find it in Part 5, you'll find it in Part 9, with the National Building Code, the Ontario Building Code, and of course the National Energy Code. There are sections that specifically look after heat, air, vapor, and precipitation. That's how the code addresses it. And the issues that are being said in the code now that weren't said before is it's a matter of design and constructed. So that puts you guys a little bit more on the responsibility side when it comes to what is being designed. We have to ensure that it's being properly constructed. There are two standards that you have to be aware of that is in today's code. CAN ULC S741, published in 2008, and CAN ULC S742, published in 2011. They are in the 2012 building code that was released January of 2014. These go beyond some of the other requirements. We'd be more than happy to come to your office and talk to you more about it. I won't be doing it today, but come up or come to our booth and we'll set you up to learn more about these presentations. The point of these presentations is that they put a lot more effort into air leakage rate, not only from a prescriptive performance, but how it's to be equated and sent back to the building, and then there's other classifications behind it. But at the end of the day, it deals with air leakage rates. It also deals with durability, flexibility, and longevity, which is where we step into the window program, or looking at windows, because it's looking at these three performance requirements that the materials you select have to work correctly. Now, unlike a lot of other types of elements within the building, they can easily be replaced. SOPREMA is synonymous with roofing membrane systems. But even at that, we expect that in about 35 years, you're going to have to do a roof repair, and it's not uncalled for. It's clearly understood. But when we deal with something that's inside the windows, the expectation is going to be there forever, and you're hoping not to go back. Where re-roofing is re-roofing, if you're coming into the wall, it's called restoration, and it has a huge capital projects number attached to it. So looking at those three values, durability, flexibility, and longevity, you need to pick membranes that you're going to be comfortable with, are going to be there and perform for a very, very long time. So this is where we are now today, taking a look at wall openings. My first comment to you as we look at this issue of how do we treat the details is to really understand what kind of wall do you have? Where is the insulation? Now I've got 3 wall models here showing a wall opening with a rudimentary window frame stuck inside of it. One of these walls is permeable, one of them is non-permeable. Anybody want to take a guess as to which one is going to be which? You're correct. This is the permeable one, and this is the non-permeable one. We can tell by the type of material that's going to be on the outside. This is an SBS modified membrane, nothing in the cavity. All of the insulation always happens on the outside of the vapor bearing. This is a vapor permeable product, so on the inside we have some cellulose type insulation. So we have a vapor retarder on the inside. Moisture compact. This is a vapor permeable wall system. From here it's really understanding, are there any other amounts of insulation on the wall, and how do we do the final connections? So have to understand, once we got that past this part, what's the order of assembly in terms due to poor planning? That's a technical term. Did someone forget to order the windows? And are we putting the cladding on and expecting to put the windows in at the end of the job? Everybody put their hands up who's got small fingers to get in here. Nobody, right? So it's understanding that order of assembly. You can't be installing wall opening materials such as doors and frames after the cladding has been done and after the air bear is done, because you can't make the connections. You need to understand the window opening. This is critical. I'm not selling windows, let's be clear. But where's the thermal break of the window opening in relationship to the rest of the membrane? Because it's going to stick the window in or draw the window back, which comes to the next comment. Do I flash in or do I flash out? Sorry, my AV guys, I may have to put the phone down. So this is a non-permeable wall. This is my window opening, and there's not a lot of value of sticking more membrane inside the window opening, because all of my performance has to happen at this stage. This is my permeable wall, and it's important to understand in the term of flash in, my air bear has to come in and make a connection to my vapor retarder. So now I'm flashing in. And we are talking about air bearer technology. We'll get to the flashing in terms of water in a minute. So for permeable systems, you're going to flash in, tie in with the vapor retarder, and then depending on if there's more insulation, your window frame is going to move out a little bit further so that that thermal break is in line with your plane of insulation. Excuse me. Does that make sense to everybody? It's important to understand the materials we're going to use for jams are different than the materials you're going to use for sills. It's equally important to understand that the material we use for head flashings is going to be different from cavity wall flashings. Does that make sense to everybody? So far we're good. So as we talk about membranes that are primerless, it makes perfect sense we start off with what needs a primer so we can understand the ones that don't need a primer. Membranes that need a primer are typically SBS modified bitumen type materials. So they have a carrier sheet and a compound and then a release paper. They need a primer on the substrates, and essentially think of primers as solids and liquids. You put the stuff on, the liquid evaporates, and you're left with a goo or a sticky residue, and that's what the material sticks to. It's important that people understand the use of a roller. You need to use a roller over the membranes because what we have to ensure is that there's positive contact between the membrane that we're putting on and the substrate you're putting it onto. Back rubs and little hand jobs, they're not what manufacturers are looking for. You have to use a mechanical device and roll the materials on. Materials commonly associated with membranes as a primer, SOPREMA Stick 1100T. Vanna White will pass some of these around. So SOPREMA Stick 1100T. I'm going to get a little loud. So this is an SPS modified membrane carrier sheet compound on the back. This is a wall flashing membrane, similar technology, carrier sheet compound on the back with a release paper. SOPREGrip FG is a fleeced face membrane compound, release film on the back. And the last one I want to talk about is SOPRESOLENE, a foil-based product compound with a release paper on the back. The value behind each of these different membranes is that it can be used under different types of conditions. Let's be clear, these membranes are air barriers, they're vapor barriers, and they're also waterproofing membranes. So one membrane encompassing all of those performance properties. Membranes that don't need a primer, they take on a different type of technology. So this is called PSA technology. So as opposed to having an SPS modified compound on the back of the carrier sheet, we have a different type of an acrylic adhesive. So PSA technology has a wetting in action of the material. It creates an early green strength where you get a certain amount of bond, and then it develops over time to a very strong bond. You end up with a thinner membrane, it's more malleable, but you still have to use a roller at the end of the day to make sure that you've got positive contact between the membrane itself and the substrates that you're sticking it to. Two of those materials that I'd like to talk about is SOPRESEAL Stick VP and SOPRESEAL Stick Flash Pro. So we passed around some membranes. You see the back side has a compound on it. With these materials here, it's a release film followed by a full application of an adhesive to the back side of the membrane. Pull them apart, stick fingers to them, you'll find it's a very, very tacky material. Primerless applications. So we can go onto clean, dry substrates free of dust and normal debris, which is common for these types of membranes as well as the others in application. You would roll it on, smooth it out, and then specifically and definitely use a roller to ensure you've got positive contact again between the membrane itself and the substrate you're applying it to. So with that, I'm going to whip through a few details and talk about what's happening here as opposed to what we're seeing on the screen. So this is a commercial jam detail where you have insulation inside, your air barrier is making a positive connection to the vapor retarder. That's the air barrier part. The second part of the air barrier is this little piece here that makes a connection from the air barrier onto the window frame. So let's call that a transition membrane. Okay, it's part of the air barrier system, but it would be a smaller section of material making that final connection to the window frame. Here is a window sill detail, similar in nature. My air barrier is complete and continuous to the back, and then the final dotted line is this part here. So for those of you who remember the old days where we used to say, draw a dotted line, your dotted line would come down through the window, into the window frame, and follow these lines down through the rest of the assembly. Sorry, just before I go there, so we've specifically identified it. Number 5 is our air barrier, and number 4 is our air barrier transition membrane. When I take a look at a head detail, I have my air barrier transition membrane, and then we have a flashing membrane. Something as a required element. These ones are making a connection for the purposes of being called the air barrier, and this one up here is the flashing membrane to redirect any water that may have gotten into the system back out of the assembly. So these are all vapor permeable designs. So I'll be a little bit louder this time. Here's my window frame assembly. There's going to be a void between the frame itself and the substrate that you're applying it to. There are tolerances as to what manufacturers will allow you to have in terms of an unsupported dimension here. When you're looking at those types of equations, it's really understanding windows that are static versus dynamic. Is there movement? Is this a curtain wall, or is this a commercial window frame? Is it operable? Is there movement? Is this steel stud construction, or is it wood frame? So all of these are going to play into just how large of a gap you're going to require to ensure the window gets done. And then we have to take a look at it's escaped.
It fell on the floor.
Oh, there it is, my backer rod. So backer rod is certainly something of a suitable nature that one could insert into these locations to give the membrane sufficient support at the back. The effort is, as the membrane is supported, we don't run the risk of another trade coming in and we have a tenting situation and then puncturing it. So we have to give it some support and stability. The permeable one? So here is a permeable flashing membrane. Due to the size of the models, I haven't done it to its full and proper size, but in essence, you're going to work systematically around the window to the bottom, installing your air barrier to make the connection to the frame and back onto the substrate in a shingle overlapping fashion so that as water is cascading down in behind the wall design, it doesn't meet any butt ends. It will be able to continue to flash over. Now we'll take a look at some non-permeable designs. Of course, the difference between those two, one has insulation in the stud space and possibly insulation in the cavity. With non-permeable designs, all of your insulation is outboard of the air vapor barrier, as we can see in this detail here. So this would either be block wall, empty steel studs. This is my air vapor barrier, and there's not a need to flash in. Your plane of air tightness and your plane of vapor control begins through here, continues, and is on its way up and out. This is a jam detail, is a sill detail, and folks, this is a presentation on air barriers. Whatever other measures you feel is necessary to flash over the veneer or the outside cladding is a whole new topic. I just wanted to concentrate on strictly what happens and where is that plane of air tightness. So in terms of a sill detail, when you did need to put something here as a flashing membrane, you would go back to one of these other types of membranes that have waterproofing characteristics. This is a waterproofing membrane in the sense that it takes vertical waterproofing. It allows gravity to take over and drain water away. These are permeable materials. put them on a horizontal surface. If water sits over time, it will change from a liquid to a gas, find its way through, and then it can easily change back to a liquid again. Okay? So you do not want to be using vapor permeable products on sills or anything that's near horizontal. The other critical area one needs to take a look at as we're doing these wall systems, while we're talking about wall details, is this particular connection here. Again, we are in a trade show that works strongly and heavily on people understanding the technologies of air barrier design and the continuity of air barrier design. And again, this is one of the last frontiers of how do we make that connection from the wall to what's happening on the roof. You can absolutely take membrane up and over there. And we have truckloads of material ready to be shipped to your store for those types of applications. Or you can look at different measures of getting underneath your parapet, because it's air movement and air pressure coming from this direction that usually creates problems up in this area, and consultants have a heyday with it. The last part of this presentation, does anybody have any questions about these two models and how membranes are going to get connected? The last part of my presentation is to look at how permeable is permeable. A lot of discussions out there, what's enough, what's too little, where does it go? So hopefully we can address this type of issue with this presentation. Brick, airspace, insulation, air barrier, stud space full of insulation, vapor retarder. Everybody get it? Good detail? We did a lot of looking and studying of the detail to see what the permeability rates or acceptable permeability rates are. And what we found is two things. There's a lot of other materials in this wall that influence air leakage as much as the air barrier does in itself. The other thing we determined is that reverse vapor diffusion can be as much of a problem as positive vapor diffusion. So let's talk about that for a second. Outside, it's a month from now, January, minus 15. Inside, nice and warm, 22 degrees. High humidity, low humidity. So the obvious draw is that vapor is going to go from the inside coming out. We have a poly vapor retarder here. Could be 15 nanograms, a type 1, could be 45 nanograms. Super 6, for example. But despite all that, by the time you finish putting up poly and drywall and putting all the nail holes through it, you're probably in the area of about 45 nanograms. Out here, I've got SOPREMA stick VP at 17 perms, or 972 nanograms. So what we can expect to see is, as vapor diffusion occurs, is going to come through the poly. Any wild guesses at how much vapor is coming through? About 45 nanograms. That's the limitations. So that would mean with our product, we could see 972, but there is no 972. If it's letting 45 through here, it doesn't miraculously grow into 972. It stays at about 45. So the amount of vapor pressure coming through here is what you're going to see happening on the outside. Now we'll be able to pass through the assembly and escape to the outside. Now we're going to switch this around a little bit, because we know there's people with membranes out there in the magnitude of 30 perms, 1700 nanograms. How is this different? Well, if we change the equation to July, it's 30 degrees outside, very high humidity, and we've got the air conditioning on. So now my vapor drive goes from here to here. And if you've got a product with about 1700 nanograms of capacity of vapor moving through the membrane, you got a lot of moisture coming through. And your barrier, he's still stuck at 45. So, back to you. We think SOPREMA that membranes at about 972, 17 perms, it will protect your building in the wintertime when vapor diffusion is happening to the out, but equally in the summertime where you've got a reverse vapor drive, you're not going to see too much moisture come through and cause condensation at the bottom. So, wrapping this all up, there are membranes that don't need a primer. They bond well, great adhesion, they have to be installed correctly, right type of substrates. There are durability issues and flexibility issues, and this is something you're going to have to muster in your design on what kind of materials you're going to specify, because there are some differences between them. SOPRESeal Stick VP was the first one I showed. This is a vapor permeable air barrier. The SOPRESeal Stick Flash Pro was the other material we held up. So this was the other one that got circulated. Has a release film on the back. Very flexible elastomeric membrane. Fantastic adhesion to, of course, dry, free of dust type substrates. You get these materials from SOPREMA. We have a full line of compatible air and air vapor barrier membranes, flashing membranes, and liquid accessories. Stop this acute air leakage syndrome. We got to understand how walls get together and help my little friend Fast Eddie here get a return on investment by properly sealing these things up. Thank you very much. Our booth is over at 1125. There's a group of us just waiting to show you the showstopper specials.